Let's go ahead and get started with today's lecture, which is going to be the first day of learning Django. So, again, as I was just mentioning, what we've talked about so far is, especially in the last two modules, has been creating and managing databases in SQL using Postgres. And then in the last module, we talked about how you can use Python in order to directly work with those databases. However, integrating Python with SQL by using just native Python and a couple of packages that you've explored is a little bit clunky. You're effectively still writing queries in Python. It's not the smoothest approach. So instead, what we're going to be doing today is using a different set of tools called Django in order to do the same thing. So Django effectively functions as a way to liaise between a SQL backend, or really any backend slash database that stores data in a given format, and Python code, which can then also be used to link to APIs or link to a front end or something similar to that. So before we jump into this, there's one sort of fundamental concept that we may have talked about. I believe we have talked about before, um, called virtual environments. So would anyone like to try to give me a definition of what a virtual environment is or what
Source
it
one.
means to you?
And to me, I guess I just view it as like whenever we want to like install a bunch of things that we don't necessarily want on our actual local computer, we can use a virtual environment to kind of hold those for the time being.
Yeah, that's a pretty good way of thinking about it. Thank you, Tisdale. Um, so the way I like to think of it is kind of like a petri dish. Like you're gonna put things in the petri dish to experiment with them and to use them, but you don't want the bacteria that go in the petri dish to infect your whole house. It's kind of similar with the virtual environment, except the packages that you're downloading are hopefully not viruses. So that part of the analogy might not translate over too well. But you're effectively creating a development environment within a specific folder that you can use to work with different Python packages. So Django is, again, another Python module. So whenever we install Python modules, things like Django, things like NumPy, things like pandas, CSV read, and there's literally thousands of them. We always want to do this inside of a virtual environment. So in general, there's three steps to creating a virtual environment or creating, running, using, I'll use the terms somewhat interchangeably. The first one is actually naming your virtual environment and creating the file structure. So for that, again, remember virtual environments are a Python construct. So we're going to say Python and then dash M, VENV. So that tells Python that you want to create a virtual environment. And then we just need to give it a name. In general, people will do one of two things. They will either call their virtual environment VENV, which is like the standard name for virtual environment, or they will name it something hyper specific to the project. Like we're going to be creating a Pokemon database for today. So you could also call it like Pokemon project VENV 1 or version 1. People will do both, however, which is good for version control. However, for today, I'm just going to call it VENV and super standard simple. So we'll give WSL a couple of seconds to run this command. So also one other thing to note, when you run a command for starting or spinning up a virtual environment, you will not get a confirmation message saying virtual environment successfully created or something like that. In general, if you do not see a message, that means you did not get an error and it's successfully created. However, don't always trust that. It's always important to know how to double check. The way that we can check if a virtual environment's been created is by checking the file structure. And we now see that I indeed do have a virtual environment folder. Now, if I switch over to my VS Code, we see that in my week 12 day one folder, I also have a virtual environment that has a bunch of different things in it. It's got an include, which doesn't have anything. It's got this lib thing. It's got in the binaries, it has a bunch of different pips and Python listings. So effectively, what we want to look for is make sure in that bin, number one, that there is an activate file in order to activate your virtual environment. And we also want to make sure that it has versions of pip and Python linked to it. If you do not see that in your venv folder, something has probably gone wrong and you may need to check it. However, again, most of the time, if you don't get an error message, your virtual environment is successfully created. Also, one other thing I will mention, as you might notice, I currently have my terminal, or in this case, WSL shell, set up in a separate window from VS Code. You will see why shortly, but it can be advantageous to have, look here, let me move closer to the microphone. There we go, that's better. It can be advantageous to have multiple shells open on your computer in different places. I don't mean having two WSL shells open or two shells in VS Code. The reason for this is what happens if VS Code crashes? Then and you have both shells in VS Code, well, then you're stuck. You have to go spin up your virtual environment again. It's possible there could be an issue in your virtual environment caused by the crash. Or if you were running a Docker server and you're typing a bunch of commands in, and then your console where you were doing that crashes, then you could run into issues when you're trying to spin the server back up. It's a lot easier for redundancy purposes to have a primary and a backup terminal is sort of how I like to think of it. So choose whichever one you feel more comfortable with for your primary. So like for example, what I will usually do is I will run all of my Docker related commands in my WSL terminal. So as in like running a Docker image, running my Docker files, or in this case, spinning up Docker containers using Docker Compose, which we'll get to shortly. I usually like to do that in WSL. And then all of the application specific stuff like testing functions or making database queries and things like that, I'll usually do that in VS Code. Okay, so back over to virtual environment. So we've confirmed that we've created our virtual environment successfully because it shows up in our file structure. And when I go into VS Code and check the folder structure, the file structure, it has a binary folder and an activate file. So now we need to actually activate our virtual environment. And I'm pretty sure it said this in the activate file. But the way we activate our virtual environment is we say source, the name of the virtual environment, which again, the name of the folder, the name that I called it up here is venv slash bin, which is again that folder that I was checking for, and activate. So unlike where we create a virtual environment, there isn't a direct confirmation of successful creation. We can see right here that we do get a pseudo confirmation, namely that when I run venv bin activate, it says here that I have entered my virtual environment at the start of the terminal. So you'll notice before then, I just had my username on the left and no virtual environment listed. Now it shows that I am in my virtual environment. However, when I enter my virtual environment, nothing changes about my file structure or anything like that. So again, I can type ls and I'm still in the same directory. I can go back and forth. I can create files, etc. The last command that's important to know is also how to deactivate a virtual environment. So that's basically when you're done, running whatever code you need to run and you're going to shut your laptop down, or you need to switch to another virtual environment or something like that. You can just simply type deactivate, and then again, those parentheses that said you were in your virtual environment go away, and now I'm back to being outside of my virtual environment. So I'm just going to go ahead and reactivate the virtual environment for purposes of this demonstration, because we're going to start doing some things with it. But does this process overall make sense? Any questions about starting, spinning up, or deactivating virtual environments before we move on?
Excuse me, I'm just a little bit confused about when you're in the virtual environment, you can still do everything as if you're not inside the virtual environment. It's like you're in or you're not in it. That just seems confusing to me. I don't quite understand that.
So the only thing that the virtual environment really lets you do is if you're running a Python script with that calls for specific packages that are installed in your virtual environment, you can run those. That's literally the only real benefit of a virtual environment. Otherwise, you can still, right now, hypothetically speaking, I could spin up a Docker container. I can access Postgres. I can touch or remove files. All of that stays the same. The only time that a difference shows up is when I am running a Python script that relates to modules or packages that I have installed in the virtual environment.
Is it so that we like it they take up a lot of space, so we don't want to download, like install every
That
package we run?
that can be part of it. Other times it's also useful to effectively you can think of a virtual environment like containerizing the packages that you've installed. So that can help to prevent conflicts. So let's say that you are building two programs on your computer. One of them is designed to work with the latest and greatest package, like package version 10. The other one is designed to work with package version 2. And package version 10 and package version 2 are really different from each other. So if you were to just to not use virtual environments and write code, write your two different Python projects, just on your computer, number one, you'd have to install both package version 2 and package version 10, which doubles the amount of space. But more than that, you could find that when you ran the code that's designed to run on package version 10, it accidentally runs it on package version 2. Or even if you specify that it was supposed to be run on package version 10, there might be some different types of conflicts or errors that show up because you've got them both installed in the same system, which is where having the virtual environment comes in handy because then I can create a separate virtual environment for one project with one version of the packages and another virtual environment for all the other versions of the package. It also makes it easier for sending your code to other people. So, for example, if I were to create a project that had 15 different dependencies, like it used 15 different other packages that someone needed to pip install, I could send them my code directly, and then they would have to go through my code and see what libraries I use and then manually pip install them. Or I can make a virtual environment, pip install things to that virtual environment, and then give them my pip list, which essentially says, here are all of the different Python packages that I have installed and I'm using in this project. And it makes it a lot easier for them to use.
That was a really helpful explanation. Thank you.
Any other questions about what virtual environments are or why they are useful?
Yeah, if we deactivate a virtual environment, um, do the packages go away or can we just activate it again and it'll still be there?
Yep, so deactivation is kind of like hitting the pause button. The packages are still there. So recall that again, a virtual environment is effectively a file structure that, again, it's located in that folder that has all those packages installed in it. When you deactivate it, you're just sort of taking yourself out of that environment. That doesn't delete the packages, it doesn't delete the virtual environment or anything like that. So that's you can always go back to reactivate the virtual environment using that bin activate command, and everything you had will still be in there.
Okay, thank you.
Any other questions before we move on to Django? Awesome. So again, as I mentioned, Django is a Python package, and we're already in a virtual environment. So we might as well just install Django. Oh, not Python. That's the wrong function. But pip install Django. So again, because it's a Python package, we install it just like we install every other package. So we'll give it a second, and we now see down here that it has successfully installed a bunch of things. But I just told it to only install Django. If I go to, again, that pip list, where I'm listing everything that's in my virtual environment, I see that I've got, pip and setup tools and Django, but it's also installing this ASGI ref and SQL parse and typing extensions. I never directly told it to do that. Are there any ideas why those things might be installed when I install Django?
Because their library is required to have Django work correctly.
Exactly. Yep. So those are dependencies of Django. Or more specifically, these and their specific versions are dependencies of Django version 5.1.4. And this is again where having having your virtual environment is extremely important because it's possible for Django version 4 or Django version 6, the dependencies and the versions of those other packages might be different. And it's important to know that and also to be able to keep track of which versions of these packages you're using and how to phase them out or bring in new ones as needed. So again, this is really one of the main benefits of a virtual environment.
If we
Okay,
wanted to install a certain version, do we just put that after the pip install Django and then whatever version?
yes, so should be able to do that by specifying the version, usually with the dash and then the specific version after. But certain types of packages will have different formats for installing different versions. So you'd have to check the documentation.
Okay, thank you.
Mhm. But in general, for packages that have numbered versions, like 3.8.1 or 5.1.4, usually you're able to specify that just by doing the dash and then the version number. And that's something that we'll see very shortly as well. So actually, wait, let's do this real quick. So the other benefit of having a virtual environment, like I said, is that you can, well, first, let me switch back over to the file structure so we can see everything that's in it. So again, I'm now back in VS Code. So this is the activate thing, which we don't need anymore. But if we take a look in our libraries folders, which before were a lot smaller, they're now kind of bigger. And they have folders that have a lot of subfolders for Django, for ASGIREF, for setup tools, for SQL parse. And that's effectively those subfolders in there are all the contents of the packages that we have installed. Now, we only install Django and its subpackages. In general, when people develop Python applications, you might end up installing a lot of different packages. I know some that I've worked on have ended up installing 10 like parent packages, and each of those had their own dependencies. So you might end up having to install like 50 different packages in your virtual environment. Now, when you do that, that expands the size of your virtual environment folder. Now, presumably, when you want to share your project with someone, you could do that via GitHub or honestly send them a zip file with it via email. You want to share the least memory intensive and least space intensive version of the project possible. So is sending them your virtual environment folder with like goodness, who knows how many different subfolders and subfiles in it, is that really the best thing to do when even if your program is super small? It isn't. But how else do you know how to tell them, or how else will they know which specific packages and versions you installed?
The
Enter.
pip list.
So pip list is one way of doing it. So you can, directly copy paste the output of the table. However, if you just send them the pip list itself, they'd have to basically say pip install and then type out pip install dash every single line. There's a way to make it slightly more effective, which is with pip freeze. So what pip freeze does is it lets you take the output of pip list, aka all of the packages that you install into your virtual environment, and send it to some sort of a file. Usually we like to call this like requirements.txt. It's just a standard name for everything that you pip install. And oh, I was not sharing the right window. That's the only downside to having a separate window for your console and a separate window for VS Code is sometimes you forget to switch windows. Otherwise, I'm a huge fan. But basically, so again, pip freeze, and then you have a greater than sign, which says, hey, send all of the stuff in my pip list to insert this file called requirements.txt. And if we go back to VS Code, we now see that I have a requirements.txt file, and that effectively contains the pip list, as Tisdale was mentioning, but not in exactly the same format. So you might ask, okay, well, what's the benefit of using requirements.txt if I can just send them the pip list anyway? And the answer is you can directly run a requirements.txt file. So if someone were to send me that requirements.txt file, I can just say pip install -r, and then I can type in requirements.txt. So what pip install -r, what the -r means is it basically says to Python, hey, I have a file of all of the required dependencies that I want you to install. Go down the list of everything in this file and just install whatever I wrote on every single line. So that's another nice benefit of virtual environments and pip freeze is that it lets you make it so you don't have to send them your entire virtual environment folder and all of its subtrees. Instead, you just need to send them one txt file that they can run pip install -r in that txt file and download the whole thing on their own. So let's see, what have we done so far? So we talked about pip list and pip installing. We talked about how to freeze. We've also installed Django. So let's get started with actually starting to create our Django project. So Django provides a framework for us to effectively create, I'm going to use the term a fully integrated full stack project. So in it, though we will mostly be focusing on Django for the backend, it is possible to create a front end using Django and HTML as well. I've done it for a couple of projects before. However, it is extremely clunky, so we will not really be relying on that too much in this course. That being said, it is possible. Also with Django, you can create multiple different backends or link multiple backends together. So if I have a project that, let's say it has a backend, a front end, but I also end up linking to a secondary database and an API somewhere else. Those are three separate applications, essentially, within one mega project. And that's the way that Django likes to organize itself as well. So you have a overall project that within that project, you create miniature apps, each of which has a specific purpose. So in order to create the overall project, so again, recall that since Django is a Python library, whenever we run anything related to Django, we generally need to preface it with a Python-m or Python somewhere. There are caveats to that, but in general, that's what we need to do. So the first thing we want to do, again, once we've installed Django successfully, frozen our requirements, is we now want to start a brand new project, which again is the highest level of organization in Django. And in this case, I'll just call my project the Pokédex project. which is what it is. And the last thing that you want to do whenever you hit start project is add a period to the end. The reason for this is so that Django doesn't create a parent folder for everything and it starts the project natively within the folder that we're already in, which is week 12, day 1. If you don't add the period, then Django will create its own parent folder for your project, which in this case we don't need it. So in general, I'm a advocate of adding the period just because it eliminates one unnecessary level of your file structure. But there are cases where you might want to create a brand new folder for your project as well. So let's run this real quick. And let's go back to our folder and see what changed. So if we go back here, you'll notice that we still have our virtual environment folder and we have our requirements.txt, but we now have two brand new things. The first one is a manage.py, which as it says here, is Django's command line utility for administrative tasks. We will get to what manage.py can do in probably about 20 to 30 minutes, but this is a extremely important file for making sure that Django can essentially run all of its tasks. That's really about it. The second thing that you'll notice is that we have a Pokédex project folder created here. And that's got a bunch of different things. It's got this init, which we won't really touch. It's got a settings folder, which will be very important going forward. And I'll break down some of the important components of it once we do one or two other things. And it's got a couple of other parts that we also will not talk about today. What I will say, though, is that urls.py and settings.py are two files that you guys will be making very heavy reference to going forward. And they're also pretty important. So whenever you create a new Django project, there's three things I want you to make sure to do. The first one is make sure manage.py exists and that it is not blank. I want you to do the exact same things for the settings.py and the urls.py. Now, Django will usually throw an error if it can't create these files or if they're already there, but even when it doesn't throw an error, it's just a good check to have is, do these files and folders exist? And if they don't, then something likely went wrong. Okay, so now that we've created our highest level of the project, the next thing that we'll want to do as well is create the sub app that we're going to focus on. Again, an app is like a specific part of the back end or part of the front end. So today we're not going to be designing a front end. We'll be mostly focused on the integration of Django with Python and SQL, which will be our back end. So we'll just call the back end a Pokemon app for now. So this is where that manage.py comes in. So we'll say Python manage.py. So we'll run that manage.py file. We're going to run the start app command. So again, remember that apps are housed within projects. We're going to start an app and we're going to call this Pokemon app and hit enter. And again, Django does not give confirmation messages. So the only real way that we know if Django is doing what we want it to do is if we go back in and see if our file structure has changed. So again, we'll go to the left and we'll see that we now have a brand new folder called Pokemon app. And in that folder, we have a bunch of different things. So before we jump into checking what all the different things are, again, this is sort of my internal self-check is, did Django do the right thing? Yes, because it created a folder called Pokemon app, which is what I told it to create, and it created a bunch of subfiles, which I also told it to create. So now we do need to change an important subfile in the project. So
Why did we put manage.py in the command?
oh, good question. Here, let me go back to nope, that's not my terminal. That looks like a terminal. There we go. Are you talking about the start app part, Tisdale?
Yes. Yeah, like I get the start app and we created it, but why is the manage.py there?
Good question. So When you start a project is sort of a brand new, again, like the highest level of Django things. So we have to do Python dash M Django because starting a project is a function of basically the Django library. However, an app is tied to its parent project. I believe you can create an app without a parent project. Actually, no, correction. I don't think you're able to do that. So disregard what I just said. And that's also where the manage.py comes in. Because again, if we go back um, to the file structure, manage.py was only created when we created the Pokédex project. And this manage.py is tied to our Pokédex project. So the reason that we use manage.py to start the app instead of Python-M Django to start app is again because apps are tied to projects. And whenever you have to do something that's tied to your project, you have to use manage.py.
So it's just like a level down from the Django.
Yeah, exactly. So it's sort of like it's a level down from the project itself.
Okay.
But that's a good question though, so thank you for asking that. Any other questions before we jump into how to connect the different things together?
Can you just go back to that and show us the code again? Because that I don't see that in our notes in the README.
Oh, it might be in a different order in the README. But effectively, so you start your project, and then once you start your project, you also start your app after.
I think it's in the middle of the page. It has the Django start project one first, and then under starting Django app, it has the manage.py startup in like the middle of the lecture.
I'm still missing the Python dot or dash M.
It's like two up. So above the starting Django app, there's a pip freeze, and then above that, it's the Python-M Django.
Okay, I got it.
I can also copy paste my console and send that to you guys after lecture if that's any help as well.
Yeah, that's always nice. Thanks.
Yeah. Yeah, because one of the things I will definitely say for the Django module, and I think this goes to something we were talking about before the recording kicked off. The only thing that I don't necessarily like about Django a ton is the fact that whenever you set up your project, initially, before you can really get to playing around with databases and APIs and linking things together, you have to effectively execute a series of commands in your console and then in the Python files to make sure everything is configured right. The rationale for this is something that I'm hopefully trying to explaining today, but it really only kicks in after you repeat the procedure a few times. And that's sort of when it makes, because I remember like when I first learned this, I was like, okay, but why do I have to create a project before the app if I only have one app? Or why do I need to do something that I'm going to do in a few minutes, which is connecting my app to my project in the settings? I thought they were automatically connected. And other, I will say somewhat simplistic questions, but that's basically why do I need to follow these steps in this order? Um, Unfortunately, the only real way to get good answers to that is to continue to repeat the process in more complicated situations until you realize, oh, I have to create an app within my project because I'm also creating two other apps at the same time for this project, and they all need to be tied to it somehow. So, okay, I guess it makes logical sense why the app has to go after the project or things like that. So if it seems somewhat nebulous or confusing at first, bear with the process. But if you have questions about why we do certain things, don't hesitate to ask because it can get overwhelming or confusing at times. All right, I'm going to assume that there aren't any other questions unless anyone would like to ask them. Okay, so we'll jump back into Django now. So we've again created our project and we created our app using manage.py. The only problem is, remember how I just said that apps and projects are supposed to be linked to each other? They aren't exactly linked in Django yet. And this is something that I think is kind of silly. And I really wish that they had automated this when you hit start app. But unfortunately, it is not the case. So when we go to our settings.py, which is again in the project directory, we need to go and add the app that I just created in the console by doing start app Pokemon app, and that shows up in my folder tree. I need to manually add this to our list of installed apps in order to fully tell Django, hey, I just created this app, even though I use manage.py, even though I'm in the same root directory as my project, please understand that this app is in my project. And we do that by simply typing the name of our app, which was Pokemon app. And I'll also just add a comma just so I don't forget it later. Now, I really wish that that was automated and it did that whenever I hit start app, but alas, it is not the case. So as soon as you hit start app, always remember that you need to manually add your application to your list of installed apps. Okay, so that's the main part of setting up Django, getting your project created, and spinning up and getting an application prepared. Um, we're now going to transition a little bit to taking a quick break from Django and jumping back into everyone's favorite containerization software of Docker before we get back to Django. That being said, are there any questions about anything that we've talked about so far before we switch tracks temporarily to talk about Docker?
I have a question. Um,
Go for it.
the installed apps list, um, could that be something that we add dynamically as far as on the outside? Like, so if I have a Python script that's going to run Django, right? So the Python script would be from the parent, and from the parent, I could just append to the variable installed app in that settings file. And would it run or no? That would cause the issue.
Um, you're saying if you wrote a Python file to just effectively edit the settings.py file and insert that line.
Well, I was thinking of it more to be done virtually in a sense, since that's a variable, right? That's Python. So I just append to it and then it executes. But then again, it would be spun up. So yes, you're right. I would need to edit the file so it would stay permanently. I was just thinking of a way to not have to manually edit that file each time.
So the other thing I will say is, even though it may be tedious, manually editing it is actually not a bad failsafe.
Okay.
Um, for the reason that sometimes you might accidentally, and this has happened to me before, I'll create a project and I'll create an app, and then I'll forget that I created the app because it got lost in my console or I didn't bother to check the file structure or something like that. And then I'll create a second app. And then link, and then I'll go back into, and I'll set up the app completely, and then I'll go into I'll try running it, and it doesn't run. And I'm like, what's going on here? Why is something not working correctly? And I go back into my installed apps, and I say, oh, I connected the wrong app to this. Let me go and remove one of them and add the other. Similarly, you might sometimes have an app or like one version of your backend or whatnot that you want to keep in beta or that you're just testing. that you don't want connected to the remainder of the project. And that's also where, again, manually adding and removing can come in handy too. So even though I do wish it was something that was automated whenever you click Start App, it's not the worst thing for you to have to manually go in to edit it.
Thank you.
Other questions, comments, concerns before we go to Docker? Okay, so before we jump into creating a Docker compose file, would anyone like to just briefly summarize for me what Docker is and what we've been using it for so far? Like at a very rough overall level.
Okay. Docker, from what I can see, it's a software that we can use as a container to run programs, isolated in a sense. That's it.
That works. So what exactly have we been doing when we set up Docker files? And again, this is an open question.
So we can share in databases.
Yeah, that's part of the rationale. I guess I was more specifically asking about what are the things that we do when we create a Docker file. Like let's say for going back to our SQL databases, what are the commands or the things that we put in our Docker files to let them spin up a SQL database?
Basically, in in a sense, we've been doing the same thing that we do in like the pip requirements, right? This is everything that is needed to run this, right? So with the Docker, we tell it what it needs, and then it will contain all of that, right? So when a user downloads it, they'll have everything right there. You can think of it like a portable executable in a sense.
That is that's a pretty good way of thinking about it. Um, the other thing that I would sort of phrase it as, and here, let's see, I'm going to see if I can pull up a an example. Um, see, do I have any on my computer? I don't. Okay, well, we can speak about it in broad terms. But whenever we've set up a Docker file, and when we've had to, write SQL queries or create a SQL database or something like that, we're essentially spinning up a local image, and it's exactly like you said, Mike. We're essentially taking those pip installs or those PSQL Postgres login, access this table, et cetera, et cetera. We're taking all of those commands and effectively putting them in one big master file that we can run when we run our Docker container, or when we run our Docker image, correction. That's the benefit of a individual Docker file. However, what we're doing today with Docker Compose is a little bit different. So while Docker files let you build individual Docker images, that again can be used to, say, run a simple server or create a simple database. Docker Compose is sort of one level above that. Docker Compose tells you how to run a given Docker image as a container. And that's what we'll be doing today. So again, to sort of contrast the two, with our .docker files before, we specifically would create individual databases and we could run SQL queries and commands with them. Docker Compose will just connect between Django and a Postgres backend. It will not physically create a database. It will not physically create, or I was correction, it will physically create a database. So it won't physically create a table. It won't modify its contents. It won't run queries. It'll merely set up the connection between our Postgres backend that we create and whatever we end up doing in Django. So in order to do that, let's see if I can, I'm still sharing my VS Code. Yep, perfect. So we'll, instead of creating a .docker file, which is usually what we end up doing, we'll instead need to create a docker compose .yaml file. And I think I saw someone's mic or hand go up. Does someone have a question?
Well, I had a question. Um, can you elaborate more on the run a given Docker image as a container? Because I thought that we were already running the image as a container when we would do docker.name and run or whatever that thing was.
Okay, sure. So with Docker Compose, it gives you a little bit more specificity, I suppose, with how you run your images. So you're correct that if you just execute it in the shell, as you mentioned, you can definitely run a singular image as a container. But when you are using Docker Compose, you can specify it to far more of a degree. You can specify, for example, the amount of memory that you want to allocate to your container when you're running it. You can specify the ports within of both your container and of images within it, and a couple of other things as well. Not to go into too much detail, but it basically helps you create a container that you're free to do things in versus the Docker file not just creates a Docker image within a container, but it runs specific commands that you tell it to. So this is sort of one level above. Does that help clear things up a little bit?
Yeah, so what I am hearing, my gathering from what you said was basically it allows you to not only do the settings for the file, but also for the environment you're in. For example, how much RAM that it is going to use this app. So it also interacts with the hardware.
Roughly speaking, that's correct.
Okay.
Yeah, I mean, I guess the easier way to think about it is like a Docker Compose, when you run that, creates a container that you can run Docker files and Docker images in. So it's sort of like you can think of it as sort of like how Django, you have your projects sitting where you can have multiple apps running in them. Using a Docker Compose, you can create a container that you can run multiple images inside of. Also importantly is Docker Compose uses a different command to run from a Docker file or a Docker image, but we'll get to that shortly. But again, the highest level difference is, again, the Docker file can run a Docker image. Docker Compose creates a container that you can specify different characteristics of, and you can run images within that container. So let's get into how Docker Compose files are different from Docker file, Docker images. And Sean, thank you for helping catch that typo. Um, I believe that YAML and YML count as the same type of file, but we should probably stick to the lecture notation for now. And also, people will pronounce the name of this file as YAML, like as if there's an A in it. So sometimes you will see people type it as YAML as well. But I believe the formal notation for it is YML. Okay, so there's a couple of different things that we need to do in order to set up our container. The first thing we need to do is tell Docker which version of Docker we're going to use. So we'll specify that we are using version 3. The next thing that we'll need to do as well is specify what we want to do within this container. So what is the purpose of us standing up this container? So we need to specify a couple of services. The first thing that we want to do is I want to create a database. I'm just going to call this DB for simplicity, but you're welcome to call it whatever you'd like. Now we can provide some details for what exactly we're going to specify our database is going to do. So first, we want to tell Docker Compose what the Docker image we want to use is, and by doing that, what backend we want to use. So remember again that there's multiple different types of backends that we can use in SQL. There's MySQL, there's SQLite, and there's Postgres. So we're going to specify first that the image that we want to use is going to be Postgres, and we're going to specify that's version 15. We're also need to now specify some of those environment variables. And as you can see, the environment variables read very similarly like a dictionary, which basically all YAML files read somewhat similarly to dictionaries. And this is where some of the stuff that I was mentioning in my answer to Mike's question about setting up the conditions for your environment or specifying how you're going to run a Docker image come in mind. So we can specify, just like we used to specify in the command line, we can specify things like our Postgres user, and we'll just set that to Postgres. We can also specify our Postgres password is also Postgres. And obviously, the last thing that we'll need to do is specify what the name of the database is that we want to do things in. So we'll call this Postgres DB, the Bravo, and that's going to be Pokédex database. And those are our environment variables. Those are the main things that we're going to specify when we tell Docker to spin up this container. We're going to say, hey, we want you to use version 3 of Django. We're going to specify that we want to run a Docker image using Postgres 15 that creates a Pokédex database with this username and this password. However, we're not done, because sure, it's great that we've created this image with this database, but I have absolutely no idea how to access it. And that's where ports and volumes come in. So we're now going to specify how we can access our database, and we can do that by setting the ports. For now, I'll set those, and also everything in general, when you're specifying ports, needs to be set with, I believe it's single quotes. So we'll connect from port 5454 to 5432, which is for 5454 is going to be the port on our host machine, aka the local machine, and 5432 is the port that gets mapped to in our Django, in our Docker container. So again, the purpose of this is to say, here, 5454 is the port that I am going to be telling Django to connect through, and 5432 is going to be the port that runs inside of my Docker image. So again, I think if you guys will recall, we did something sort of similar to this when we ran our Docker files and specified which ports we would use to access the SQL database. This ports feature here effectively does the same thing. And then there's a couple other things that I'm just going to copy in for now, and I'll send some documentation about those because they're a little bit more cumbersome to explain. But volumes and Postgres data are related, effectively related to the type and amount of content that we're allowing Postgres and our database to use within our Docker image. So again, don't bother so much about these last parts, but the main things to keep in mind is everything above that. So when I run this docker compose.yaml, I'm going to tell Docker, hey, I want you to spin up a container for me. Within this container, I want you to connect to this SQL database using the Postgres 15 image. You're going to access it via port 5432 in the container, which is connected to port 5454 on my local machine. And then we can start doing stuff with it. But that is the main purpose of a YAML file, or in this case, this specific one. I know that I just said a bunch of different things and walked through a file structure that looks confusing. Would anyone like to ask questions or seek clarification on any of those points before we keep going and talk about how we integrate it?
Just to clarify, we're using Docker Compose for the sole purpose tonight to set up a database.
So we're not using it to set up the database, but we're using it to set up access to the database.
And then we're going to use Django in order to insert data values or table values or column values and all that.
One step above that. So we're going to use Django to create tables and the values in those tables. So the only thing that we're doing with this docker compose.yaml file is we're saying, hey, Docker, just so you're aware, I want you to spin up this container and I want you to, in this container, have an image that connects to this database. I don't want you to do anything with the database. I just want you to connect me to this database. Then we're going to use Django to actually start populating, create the tables, put the data in, manipulate the data, and all of that stuff.
Okay, because I'm trying to compare it to what we did before, and if I think I remember correctly, we had just a Docker file that created an entry point, right, for the database.
Yes, so what we did before was we only created a Docker image, which again is what we did before is kind of this part over here. We only created the image and some of the environment variables. But all of that that didn't allow us to directly connect a external software like Python in order to create everything within the database. We kind of had to manually do that in SQL. So that's what the benefit of the YAML file is, that it allows us to do that by exposing a port directly.
Okay, yeah, because we had the init file with SQL to create all our database tables and all our insertions.
Exactly.
And then once we ran the Docker file, it would do that. And then there was no like updating it really, unless you kept the container open and you updated it.
Exactly. Yeah. So in this case, by setting up that sort of port-to-port access, which will also replicate in Django, that will allow us to create our database using Python in Django, to update our database using Python and Django, to make calls to our database using Python and Django, and all of that stuff without ever having to touch SQL itself. That's really the main benefit of this.
Okay.
Does that make sense to everyone else as well? Kind of.
I have a question.
Mhm.
Volumes. I see that you're giving it a path. What is that? And also, is that a path that is constant regarding Postgres?
So we will not be talking too much about volumes for a little while. But the gist of it is volumes are effectively a data storage mechanism for storing data outside of containers. Um, so for example, if let's say, here I have my database, when I stop running my container, I don't want to completely wipe my database away because, I've put time and effort and Django code and data into it. I don't want all that to get wiped out. So what volumes let you do is it lets you persist the data that you had in that container outside of that container later on. So that's why it's important to keep volumes in there so that, again, everything you had doesn't get deleted. Um, but you can place additional constraints on it later. That, well, again, we'll get to at another point. But does that sort of help?
Um, yeah, so it's just basically a storage. It's just
Yeah, you could say that.
like a logical volume, or I mean, not to go down that rabbit hole, but it's just storage. So
Yeah.
okay, thank you.
Other questions. Again, understanding this is a bit important for the stuff that we do over the next few weeks. So I know I may be taking a lot of time to go over this, but I want to make sure that the overall concept of what we're doing with Docker containers, and how it's fundamentally different from what we did before with Docker files and Docker images. Okay, so if there's no questions right now, we've got a couple more things to do before we can start actually creating our databases. And I know the entire purpose of tonight's lecture is to teach you guys how to create databases in Django, and we will get there just as soon as we finish setting things up. This is the other slightly annoying part of Django is in SQL, when we're just doing stuff with Postgres, it's a lot easier to simply create your SQL database, enter into it, and then you can start creating tables on the fly. With Django, there's a good number of, some might call them complications, some might call them safeguards, but of things you have to do before you can get to that point. So so now that we've created our Docker Compose, we're not going to run this just yet. The first thing, before we run our Docker container, we first need to connect or to tell Docker, which again, or to tell Django, which again, we're not running anything with Django right now. We're not running anything right now. Before we start running stuff, we need to tell Django that the database that it's looking for is going to be spun up by this Docker server. And that is done in our settings.py in the databases section. So and here it tells us what our default database is. It says that the default engine is going to be SQLite 3, and the name is going to be this base directory / database.sqlite 3. That is completely false in this case. That may be Django's default, but we are not using SQLite 3 to set up our database. Why? Because we're using Postgres. And we need to specify the engine, the name, the port, and a couple of other things. So let's go ahead and do that right now. So the first thing that we want to tell it is that the backend that we want to use is not SQLite 3. It's actually going to be the PostgreSQL engine. The name of it is going to be whatever name we specified in our Docker Compose for the database, which is PokédexDB. So we don't need to have the space directory. And we'll just add quotes and tell it it's PokédexDB. And then we need to specify a couple of other things. We need to specify a user, a password, Because again, all what we're doing by setting up this database equals is we're telling Django, hey, just so you're aware, here is the database that we're going to be manipulating and playing around with, and here's how to get there. So again, think of this sort of like when you're typing your PSQL in the shell and you're saying what username, what host, what port, what password, what database to connect to. We're doing the exact same thing by specifying all of that in our Django settings for telling it what database to go to as well. We need to specify, let's see, user, password. We need to specify the host, and we also need to specify a port. So we can get all of that from our Docker Compose because we specified that up there. So we have our user is Postgres, our password is also Postgres. Our host is going to be the local host on our machine. So that's, again, whatever you're running, your local host is just in general the name of your local machine. And then the port is going to be the port on your local host that you access, which is 5454. Yeah, so by this Docker Compose file, we'll set up a connection between your local computer's port 5454 and port 5432 in the container. So when we're accessing it from the local machine, which is where Django works and lives, you're going to access your database from port 545. So again, all we're doing here is just setting up telling Django, hey, remember I told you I want to do stuff in a database? Here is how to get to that database. So this is not connected to Docker itself in any way except because it connects over via that local host port. Questions? All right, now we still have a few more steps to go before we can start playing with the databases. So the first thing is, again, recall that we just created that Docker Compose YAML file, and we've specified how we want our container to operate and what images we want to run in it. However, we haven't actually run the images or run the container or run anything in Docker. So when we run a Docker image, we usually have to do Docker build ... However, this is not a Docker image. This is a Docker container. And so I'm just going to go to list all the files to make sure I'm in the right directory. We have our Docker Compose. In order to run a Docker Compose file, all we need to do is type Docker Compose and then up. And that will spin up our Docker container and all the images within it. So if we hit run, oh no, what are you saying? Validating. Version must be a string. Okay, let me go back and change that. Let's see. Oh, I typed version 3 without quotes around it. Well, let's see if I can change that and put some quotes there. I'll try that one more time. And as you can see, a lot of stuff is happening now. Now let's go back up to the top. So the first thing is that it's set up this network. It's set up a container, which is again the overall container that I said I wanted it to set up. It's then also created an image within that container and a database within that. So that's going to be this DB1 is effectively the image within our overall container. So then it says a bunch of other things. It's then spun up our server and it creates the database called Pokédex DB because that database didn't exist before we created it. We see here that it's doing this inside the container in Postgres on port 5432. And let's see, what else does it say? Got a bunch of stuff about background files. Oh, and then here it says that the Postgres init process is complete and it's ready to start. So it started Postgres. And then lastly, the last thing you always want to make sure that you see is it says database system is ready to accept connections. You always want to make sure it says that at the end. Now, the reason for that is if it doesn't say the database system is ready to accept connections, then Django is not going to be able to access your database and do things with it. So that's always the last thing you want to make sure. Now, also, we can take a look in Docker Desktop, which I think should be shared now. And we see here that we have a week 12 day one, which is the overall name of our container that we have. And within that, I've got this DB1 sub thing that's running as well. And that's got an image associated with it, and the image there is called Postgres 15. And we see here that it navigates from my local host 5454 to the container port 5432. Okay, this is all just verification and making sure that our Docker Compose is running as expected. And it looks like it is. So now, again, I mentioned that I always tend to keep one console running with anything server related or Docker related. And that's usually what I like to use my WSL shell for. So I'm going to keep this running in the background because I think it's always useful to have that open just in case you get error logs or something decides to crash. And then I'm going to switch over pretty much full time for the rest of lecture to the WSL shell. Or sorry, to VS Code. Okay. Actually, I just realized we've probably got about 20 to 30 minutes left for lecture tonight. Do you guys want to take a 10-minute break or do you want to power through the rest of it?
Break is good. I don't know what.
Is there anyone who does not want to take a break? Okay, so let's get back to what we were just talking about before we took our break. So we discussed how to set up a Docker container using Docker Compose and YAML files, and how to connect Django to our databases using the database settings. And we specified that we're using a Postgres database with various other characteristics, and we're again connecting to it from our local machine with the local host, and port 5454 is a port that we specified, and our Docker Compose is connected to 5432 in the container. So effectively, what we're saying is Django can go to port 5454 on your local machine. From there, Docker connects port 5454 on your machine to 5432 in the container, and port 5432 in the container is linked to your database. So it's kind of like a multi-step process to connect Django to your database. But that was the point of the Docker for roughly speaking, the point of the Docker file, the Docker Compose file, and the settings.py. We don't need the Docker Compose anymore. We're going to close out of that. And let me go ahead and spin up a shell in here. So we'll make a new terminal. And you'll notice that I am still in my virtual environment. So whenever we're doing stuff with Django, you always want to stay in your virtual environment, again, because that's where we install Django. So the first thing that we need to do is something that I forgot, which is we also need to install scicopg3. So scicopg is a Python library that helps Django liaise with Postgres. So we can just install that by doing a pip install. So we can say pip install, and I'm just going to reference my documentation to make sure I have the name right. We don't want to install scicopg3 itself, but in general, you will all want to install the scicopg binary because Django tends to play a little bit more nicely with that. And that's also, I've run into issues before where installing scicopg2 or scicopg3 doesn't end up being compatible with other versions of Django. So it's always, in my opinion, a good idea to install the scicopg binary. So we'll run that very quickly. It says it's successfully installed. We see that scicopg and scicopg binary have also been installed. And then I'm just going to do a pip freeze into my requirements.txt. We'll just pop open our requirements. And we see that scicopg and scicopg binary are listed. So again, the only reason we are installing those is because my headphones might die, so I might have to switch audio at some point. But the only reason that we check the requirements is to make sure that the new things that we downloaded are successfully in our requirements.txt file. Once we've done that, we are finally ready to start modifying things in our databases, which is like, what, an hour and 15 minutes into lecture? So congratulations on making it this far to the actually exciting part. So Django doesn't let you modify databases and tables directly. Why, like in SQL where you have tables, Django instead has something called a model. And a model is basically like a database, but with a few caveats. So number one, models are tied to apps, not projects, but apps. Now, if we go into our Pokemon app and we go down to our models.py, we see right now that this is blank. And that makes sense because we haven't created any tables in our database. So why would there be any models in our database? Because models create tables. So let's go ahead and add in some models. So recall that, again, Django is a Python package. So everything that we do in Django is going to be in Python notation. So when we create a model, we're effectively going to create a model, which again creates a table in Postgres by using Python classes. So we'll just define our initial class. We can call this a Pokemon because that's what we're designing. But we're not just going to create a regular class. Instead, this class is going to inherit from the Django models.model. We will not discuss what models.model is today specifically, but think of models.model as Django's sort of like template for converting from a model Python class to a SQL table. So that's why we always want to inherit from this models.model is because it connects our custom-made classes and it tells SQL how to make those into tables. So we're not going to code any actual SQL when we deal with Django, just Python. So we've created our rough template for our class, but now we need to actually create some fields. So when one plays Pokemon, there's a couple of essential features that every Pokemon has. They'll usually have a name for Pokemon, and your Pokemon will probably have a level. So these are going to be two attributes of our class, and we can't specify exact values for them, but we can specify what types of value go in these. So if you'll recall when designing tables in like the database diagrammer or designing them natively in SQL, you can specify if a field is supposed to be a character field or an integer or a float or a Boolean or an email or something like that. We can do the exact same thing natively in Django. So for example, I can specify that the name field is going to be a models.char field, or also called a character field or effectively a string. And we can specify some attributes of it if we wanted to, but we won't do that right now. The other thing we can do is we can also specify a level. And here we can say that my level is only going to be an integer field, and I'm going to specify that the default level of my Pokemon is going to be level 1, which makes sense. Most Pokemon usually start at level 1 and then they go up from there. And we don't really have a default name for a Pokemon. Pokemon can be named whatever they want. So that is all we have to do in order to create a table in SQL through Django. So what type of table does this create? So we'll see this more concretely later. But what Django will do is it'll go into the database we specified, which is going to be our Pokédex DB. Inside our Pokédex DB, it will create a table for our Pokemon, and it will create a table with 3 columns. The first column it will create is going to be an ID column, which is going to be our primary key. It'll then add another column for a name, which is going to be a string value, and then it's going to create another field for level, which is going to be an integer. You'll notice that we never specified in our Pokemon class that we want to create a primary key. This is one of the nice things about Django is it automatically creates your primary key for you. So even if you forget to create it, don't worry because Django's already done, which simplifies things a lot. Are there any questions about the syntax that we use to create models in Django that will then get translated into SQL tables?
For the levels, the integer field, are we defaulting to start at 1 so it doesn't include 0?
Yep, exactly. You're allowed to set whatever defaults you want to for fields, and we can set the default to be this if you wanted to, or -5. I'm just setting it as 1, just A, so I can show you guys how default fields work. But also because 1 is greater than 0, and no one wants to start at a level 0.
Thanks.
Kumar,
Yes.
you said that it automatically decides which attribute is the primary key? Is
No.
huh?
It will automatically, if you don't specify a primary key,
Uh,
it will just create a primary key for you. And it will usually name that primary key. It'll usually call it ID.
okay, thank you.
Yep.
So that means if you
Um,
want to, I'm sorry.
no, go
If you
ahead.
want a if you want a specific name for the primary key, then that's when you would put it in the table, I guess.
Yes. So if you want a specific name for it, and we'll get to this later as we actually talk about developing models, then it'll create, excuse me, then it'll allow you to specify that with a primary key field. But also, the other benefit of Django automatically creating primary keys is if, let's say, you have 2 Pokemon that have the same name. Like, let's say someone puts 2 Charizards in their database. One of them has level of 1, one of them has a level of like 50. If you didn't have a primary key, you wouldn't be able to differentiate between them as easily, which is why it's a good thing that Django automatically creates a primary key so that even if you don't have unique Pokemon and you want to create another one that's identical, it lets you do that, but still differentiates them in your database. Any other questions about how we go from this model class to SQL implementation? And again, keep in mind, I have not written anything in SQL yet, or at all. Everything we've done is we spun up that Docker container, using those commands, and everything else we're doing is all in Python. Perfect. So now that we've specified that we want to create this table of Pokemon with those columns, we need to let Django know that we want to create this as a table. So the first thing that we need to do is it's a two-step process. The first one is we have to make migrations, and the second one is going to be to migrate our database. So we do all of this through our manage.py file, which is over here. So always make sure when you're doing stuff in Django, you're in the console, that you are in the same directory as your manage.py file, which in this case we are. So we're going to say Python manage.py, make migrations. And what make migrations does is it tells Django, hey, just so you're aware, I made some changes to my models. My models affect my tables. So could you please register in your mind that I'm going to mess with my database? So we hit make migrations, and we see here that says that in my Pokemon app, I've created a brand new model for Pokemon. And it also created this little migrations folder in here that says that I've created a model with the name of Pokemon and a couple of fields. And as you'll see here, it's created a primary key field of ID. Even though I never told it to create the ID field, Django did it anyway, because yeah, that's one of the good things about Django is it does that automatically. So we've now told Django, hey, create this field for me, please. However, it hasn't actually created this field in our database yet. Once you sort of think about making migrations, kind of like running a git add, and then you eventually have to actually hit git push and git commit in order to push your stage changes up. That's kind of like making migrations and migrating. So you can think of making migrations like git adding your changes that you want to make to your database. And then when you run migrate, you're pushing your changes to your database permanently. So we run migrate, and now if we take a look up here, we see here that it runs our migrations and it does a bunch of stuff. You want to make sure everything says okay. And then ideally, something should have now been changed in our database. So I'm going to go back to my shell, where if you recall before, this is where I'm running my Docker container. And last time we stopped at this database system is ready to accept connections. But we now see that it's gone through some other stuff. So hasn't added, let's see, it's added a couple of files and may or may not have added some things to our database, which you can see because it says write is 4.4 seconds. So something happened to our database as a result of us running some code in Django and in the Python shell. However, what did we do? Well, this is something that we're going to need to check. So let's go ahead and see if we can take a look inside our container and see what's running in there. So the first thing that I'm going to do is I'm going to type docker ps so I can see what containers are running. And we have this container ID, and I've got this W12D1 DB1. So that's going to be the name of the thing that I'm going to docker exec into. So, and you guys remember this formula, we say docker exec into a specific image with a name, and then we're just going to we're going to check it out using Postgres for now. Then we'll talk about how to check it out using Python, which is one of my favorite things. So we'll go into it by checking Postgres. We'll make sure that it's on our local host. Let's see, what else do I need to specify? I need to specify the port is going to be 5432. The username is Postgres, and I also need to specify the actual database itself, which is, let's see, what did I call my database? I called it, let's see, I wrote it somewhere. Settings. Yep, called it Pokédex DB. Pokédex DB. So again, the command I'm running right now is a command that you all know and probably don't love, but it's the one that when are running a Docker image that has a Postgres database running in it, here's how you can access into it and then open up the Postgres command window. So we can do that very briefly. And we now see that I've entered into my Pokédex DB and I can see all the tables inside it. And let's make this terminal a little bit bigger. So you'll notice there's a lot of tables in there. In fact, there's 21 tables inside this database. I only told Django to create one table, which is this Pokemon models.model table. And we see that down here in this Pokemon app underscore Pokemon. So it always, whenever you create a model in Django, it'll create a table for that model with the name of the app first, and then the name of the model second. However, you might ask yourself, rightly so, what on earth is all of this other stuff that I did not tell Django to create? And these are all things that that you will use in probably 4 weeks from now. So don't bother about that stuff. But for example, if you were to create users or groups, if you had like a site that you wanted to have logins for, that's in about this upper half. Then we have a table of Django migrations, which keeps track of all the migrations that you've made. So that way you have a track record of them, and so on. But that's not important. The main thing to focus on is that we've created our Pokemon app Pokemon table, which is exactly the thing that I told Django to create up there. Now, I want to make sure that that table actually has no data in it, because I didn't put any data in, number one. And number two, that it has all of the columns that I'm expecting, which is an ID, a name, and a level. So we're going to say select star from that table, which was Pokemon app Pokemon, and take a look at that. Without writing a single piece of SQL code except this query, we have successfully been able to create a table in a SQL database entirely through Python that has a primary key field. It's got 2 custom fields that we also create. Now, this is like the coolest thing about Django is you don't have to write any SQL in order to set up and adjust and alter and use a database that you make. So if that's that's the main takeaway I want you guys to take from tonight's class is you don't need to write any SQL, but you can connect Python to a SQL backend using Django. All right, so there's one or two other things that I want to run by you guys very briefly before we wrap up for tonight. The first one is, well, okay, it's all well and great that I can create a database using Django, but databases are kind of boring if they're just shells. Like databases, the first word in the database is data. How on earth do we add data to a database in Django? There are a plethora of ways to do this, and we will get to more complicated ones over the next few days and honestly few weeks. Tonight we're going to talk about 2. One of them is a method that you guys are going to know and will not love, but it's very basic. The other one is a nice user interface that Django gives you automatically to simplify testing and administrative purposes. But first, we're going to talk about the Python shell. So, and if I just type Python in the shell, I can, enter a Python shell and start typing commands in, and that's great. But that doesn't let me do anything with the database. Thankfully, Django has its own custom Python shell that we can run by saying Python, we run our manage.py file, and then shell. And this looks exactly like your normal Python shell. The only difference is this Python shell is connected to your models.py and your entire Django project. So what we can do is I can import my models, so which will effectively allow me to connect my shell with my table. We can say, let's see, from where is this located? Pokemon app.models. I want to import my Pokemon model. And again, this is the exact same thing as importing a class. And we're back to Python now. So we're just importing this class into the shell. And now I can create a brand new Pokemon. So let's say that this is going to be Pikachu is going to be a brand new Pokemon. I do not have to specify an ID because again, it's a primary key that Django creates on its own. And I can specify that the name of this Pokemon is Pikachu. And I can specify that his level is going to be like, to make it 10. So, okay, great. I've created a Pokemon. However, this is sort of like you're filling out fields in a form, but you haven't hit the submit button. Or to hit the submit button and push your new Pokemon to your Pokemon database, we then have to save the Pokemon or save the entry, save the model to our table. We do that by doing the .save operation. Now, how do we know that we've successfully saved to a database? Well, this is effectively, again, the same thing as running an insert into function. And then you put the semicolon at the end, that's effectively the same thing as .save. So we can check the contents of our database by going to Pokemon.objects, which is all of the rows of the table, and then we just do a .all. This is pretty similar to a select star from Pokemon. It's effectively the same command. However, here we get a query set with Pokemon objects. This looks a little bit nebulous, and we'll get into how to break those down and what query sets really are over the next few days. The main thing to note is right now in my Pokemon database, we have one Pokemon object. Now, let's say that I want to add in a second one. So let's say I can call this a Charizard, and we'll create a brand new Pokemon. We'll call this Charizard, and we won't specify a level. So that way we'll see if the default really works or not. And we'll say Charizard.save. And if hypothetically, if I check back in my database, we now have two Pokemon. We have Pokemon with ID 1, which is most likely our Pikachu, and our Pokemon with ID number 2, which is most likely our Charizard. However, we should probably actually check this. So let's exit out of the Python shell. Let's go back into Docker by running our Docker exec. We're now back inside of Postgres, and we can again run our select star that we were just running before. And take a look at that. We have, again, without touching SQL, except for that select statement, we have successfully added or inserted into this table of Pokemon two custom entries. In the first one, we specified both the name and the level. In the second one, we only specified the name, but the level is adhered to by that default equals 1 that we put above. So that just goes to show that adding default fields does actually work. There's one other cool trick I want to show you guys before we pause for questions. And this is a way to modify your databases that is a lot more aesthetically pleasing. So you'll probably cover this, I think, next week or the week after, when we start talking about user authentication and very complicated databases. But Django has something called an admin panel. An admin panel is basically a place where a website or a database administrator can go in to see various aspects of the database in a nice pre-formatted format. It looks a lot better than the shell. So I use this all the time to play around with my databases. So the first thing that we need to do is I'm just going to say these steps out loud, and not really explain what's going on in as much detail as I was, because this will touch on some more advanced topics, but feel free to stop me if anything is unclear. So in order to create that admin login with the nice user interface, we have to create an admin web page, and the admin web page needs to be connected to our models that we just set up, aka we need to tell Django to connect the table to the admin database. So I first need to import my models. We can say from models, import Pokemon. Again, it's just like you're importing a class from another Python file. And now I just need to register my class as a thing on my admin site. So we'll say admin.site.register Pokemon. All I'm doing by saying that is I'm telling Django, hey, if I am a site admin or an admin on this database, I want to make sure that I can go ahead and mess around with this table, that I have access to it. That's the first thing. The second thing that we need to do is we need to create a super user. So we're going to say Python manage.py create super user, where a super user is basically creating an admin user. So for your database. So I'll just say I like to use test a lot. So username is test, email is test@test.com, and the password, well, I'm not going to say my password, but if you can guess it, I'll give you 100 brownie points. Hint, it's very similar to the username and email address. So if you create it, it should say that super user has been created successfully. And now we get to do something that's really fun. So we're going to go ahead and say my Python manage.py run server. And what run server will let you do is it will create a web page that you can open in your browser in order to mess around with some of the stuff in your database. So we're going to go ahead and hit that. We now see here that it says that it's starting a development server on localhost 8000. And if you open that, the first thing you should see is you get this very nice looking web page that Django will create as a default to tell you, hey, when you hit run server, things are not glitching. Everything looks good. However, I don't see anything that looks like a database in here. So how do I go into my database? You might be asking. That's a great question. So you just need to say localhost 8000/admin in order to go to the admin page. And then again, we get to this super nicely formatted web page. You just put in your username and your password that you set for your super user, hit login. I'm sure that password was found in a data breach. It was definitely not secure. And then we get the format of this is infinitely superior to the shell. So forget about groups and users because we don't have any of those. We never set those up. However, if you take a look inside our app called Pokemon app, we have an entry called Pokemons. If I click that, you see here that we have 2 Pokemon objects. I have 1 and 2. If you take a look, the first Pokemon object, hey, that's the thing that we created in Python that is now in our SQL database that is also now in my web browser. This is effectively like the crux of full stack engineering. You're creating something in a backend server somewhere. You're connecting it through Python to a website that lets you change things. I can change this from Pikachu to anyone know another Pokemon? My knowledge of Pokemon is not great.
Squirtle.
Perfect, thank you. So we can change this Pikachu to a Squirtle and change this level from 10 to 15. And I can save that. And if I go back, I've changed something in my database using a website. In the same way, I can go ahead and also add on a brand new Pokemon. And you'll see here that it specifies our default is at level 1. Let's go ahead and change, let's add Pikachu back in. Pikachu. And we just added a third Pokemon. We are manipulating our database from a website that we've connected to our database using Django. in my opinion, this is like one of the coolest things, and I can go on about this for ages. However, I've also been lecturing for 2 hours, and I don't think I want to keep going on about this for ages.
And
That being said,
this will save because of the volumes portion in the compose, the Docker compose. So like if you closed
yes,
out the container and everything, this is saved. You restart the
that's
container
correct.
in there.
Yep, because of the volumes. And again, this does the exact same thing as what I was just doing in the Python shell in manage.py. This and that do the same thing. This is just looks better and is a little bit easier to play around with.
And you're able to run this because you did the Python-m manage.py run server, and this is that
Exactly.
one. And that's inherent to
Yep.
Django.
That is inherent. That is inherent to Django. So we will talk more probably in about 2 to 3 weeks about what run server is and what it does. But for now, the only thing I want you guys to think about is run server spins up this cool looking website that you put a /admin on it. And then after that, you get access to your databases in a really easy to see form. And also, if you, let's say that you want to make a change to your database, like in your models, you just stop running the server. I think it's, yeah, here it says you hit Control C, and then you can make your changes and then rerun your database. But also, just so I can like fully demonstrate to you guys that what we just did on that website is reflected in our Postgres database, we're going to go back here and do that select statement again. And those changes that I just made in an HTML file are reflected in this website. That to me is like one of the coolest things possible. So that was a definitely not brief, but tried to keep it that way, introduction to Django and Docker Compose. I'm going to go ahead and switch off the recording for now. For those online, thank you for listening.